Hello. In this video, we want to graph y equals 2 sine of 1/2 times x minus 2 minus 4. Now, this is already in the standard form that we need it to be because there's a 1 in front of the x, 1/2 in front of all of this, and then all of this is part of the argument. Now, this is the first time we're combining all the transformations into one. Now, this is working with sine, so our parent function here will be sine. So y equals sine of x. Alrighty. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now what we can do is we can work with the x's and y's individually. So I'm going to work with the y's first. So notice that there's a 2 and a negative 4 here. I'm actually going to do both of those at the same time. So y equals 2 sine of x and then minus 4. Now this 2 is multiplying, oops, sorry, I forgot the y values, didn't I? 0, 1, 0, negative 1, and 0. So this 2 is multiplying all these y values by 2. It's a vertical stretch by a factor of 2. And this negative 4 is subtracting it. So with the order of operations, multiplication always happens before addition or subtraction. So begin with this and then do that. So what we're going to do is multiply by 2, then subtract 4 from the y values. And that keeps all the x's the same here. So 0 is still 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, 0 times 2 is 0, minus 4 is negative 4. 1 times 2 is 2, minus 4 is negative 2. 0 times 2 is 0, minus 4 is negative 4. Negative 1 times 2 is negative 2, minus 4 is negative 6. 0 times 2 is 0, minus 4 is negative 4. Good. So which did the vertical transformations? Now notice that that 2 was a vertical stretch by a factor of 2. And the negative 4 was a vertical shift of minus 4. Good. Now looking up here, we have the 1/2 and then parentheses x minus 2. So let's do that. That gives us the final table of 2 and then sine of 1/2 x minus 2 and then minus 4. Now this actually is missing something here. I want to put not a 1 there. Here. I don't want a 1 there. I want a pi there. There we go. That's better. So pi over 2 times x minus 2. That's better. Now, let's think about this. XY table. The y's are going to stay the same because only the x's are given here. So negative 4, negative 2, negative 4, and negative 6, and negative 4. Good. Here's the thing, though. Working with this, we have to divide by pi over 2. So divide x by pi over 2. And then once you do that, you add 2 to the x's. But dividing by pi over 2 is the same thing as multiplying by 2 over pi. It's the reciprocal. So 0 times 2 over pi is 0, and then plus 2 is 2. Then pi over 2 times 2 over pi, well, that gives us 1, and then plus 2 is 3. Pi times 2 over pi is, well, pi times 2 over pi is just 2, plus 2 is 4. Now notice that we're just adding 1 each time. So once you've seen the pattern, you can just keep going. And there you go. So it's 2, 3, 4, 5, and 6. So notice that these coordinates transform into these coordinates. Awesome. And this allows me to just go ahead and put these down. Now I'm going to go ahead and write down A is 2, which means that we have an amplitude of absolute value of 2, which is 2. B is pi over 2, which tells me that the period is 2 pi over pi over 2. Now notice that those pi's cancel each other, and that 2 goes in the numerator, making that 4. So the frequency would be 1 over 4. C is what? 2. So the phase shift is 2, and D is minus 4. So the average here would be minus 4. Awesome. Now that we know all that, let's go ahead and go up here. I'm going to make this as 1, 2, 3, 4, 5, 6, 7. So -2, -4, -6. And this doesn't really matter if we go up or not because everything's in the negatives. And then we're at 2, 3, 4, 5, 6, which means I'm going to make this 1, 2, 3, 4, 5, 6, 7. Good. And then make sure that we just plot these 2, -4. 3, -2. 4, -4. 5, -6. 6, -4. And there you go. Excellent. Now notice that this is in fact oscillating about this line, y equals -4. That is the average. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.